David Smith here with yet one more Flipped Classroom math lesson. 3 tips before we start. First, remember that you can slow down or speed up the playback to suit your needs. Second, you can pause the video at any point to catch up with your notes or jot down questions. Third, you can turn on the captions and read my words on the screen. Okay, this is part 4 of our linear modeling series of lessons. So let's do this. I want to remind you of something before we start. Remember, the domain of f inverse of x is what? And the range of f inverse of x is what? Now, you have to dig back or maybe flip back through your notes and see if you can figure out what that is. Okay, let's see how you did. You just have to remember with the inverse function, the domain of one is the range of the other, and the range of one is the domain of the other. So the domain of f inverse of x is the range of f of x. And the range of f inverse of x is the domain of f of x. Now, right off the top of my head, I can think of some tricky multiple choice questions that you might see that would require that you understand that. Okay, let's do a graphing problem that relates to domain, range, and inverse functions. So I've put this function up here. We don't know the math on it yet. We can figure it out pretty easily. I think you have the skills for that. But we're not going to use that right now. We're just going to play with domain and range first. So what is the domain of f of x? And notice how there's no arrows at the end. So this function stops here. It doesn't go on forever. So go ahead and take a minute and write down the domain of f of x. Okay, let's see how you did. The domain is the range of x values. So we have -2 here, this point there, that's -2, and this one is 4. So this would be -2, 4. I'm using the simple notation with the square brackets just because that's nice and quick. Okay, now try to do the range of f of x. So if you remember, the range is the y values. So now let's take a look. We go from 1, 2, 3, 4 negative, all the way up to 5 positive. So the range would be -4 to 5. Okay? So that's the range of f of x. Okay, so let's make our sketch, this last part here for this problem. And what I'm going to do is I'm going to write the domain and range of f inverse of x. So let's do that first. The domain of f inverse of x is going to be the range of f of x. So that's -4, 5. And the range of f inverse of x is going to be the domain of f of x, which is -2, 4. Okay? Now, take a look here. In f of x, this function goes from the point -2, -4 to 4, 5. Do you see that? This is -2, -4, and it goes through all these other points, and it goes to the point 4, 5. So, f inverse of x is going to go from the point -4, -2 to the point 5, 4. So I'm going to graph those points, and then we'll get our function. So -4, 1, 2, 3, 4, -2 would be out here. And we're going to use a convention for marking this. This is going to be a prime, because this is the point on the inverse function. And then let's graph the point 5, 4. So that's 5 out and 4 up. That's going to be right there. And we'll call this one d prime. And now I can just draw my, my function line between these 2 points. Let's see if I can do it straight. Not too bad. It could be straighter, like in there, but that's not too bad. Okay, so now I've got my, let's see, that's f of x, so this would be f inverse of x. And there we go. Now, there's something to notice here. There's something interesting about this graph in terms of symmetry. So pause and think for a minute and see if you can figure it out. And if you do figure something out, there's something else you can put on this graph that kind of shows that symmetry. Okay, if you noticed that a 45-degree line, a line with a slope of 1, goes right through the middle, you are right. So this is the line y equals x. And for a linear function, the inverse is always a reflection across the line y equals x. So we can see here, b prime is going to be right there. C happens to go through both functions, so that's a point that satisfies both functions. So there we go. There's your graph of f inverse of x. Okay, let's build on what we did in the last board and do another problem that's a little different. Okay, so here we've got g of x. This is some exponential function, and I've graphed it for like a couple, 3 points. And now I'm asking you, draw g inverse of x. Now, we don't know what the equation is for this function, so we can't plot points. So how would you do that? Pause the video for a minute and see if you can use one of the 2 techniques from our last board to draw g inverse of x. Okay, let's see how you did. I'm going to use that 45-degree line trick, that slope of 1, that y equals x. Here's that line. This is the y equals x line. And now what I do is I just reflect the function across the line. I'm going to switch colors. So if we call that point A, then A prime is going to reflect right across that line, and there's A prime. So it takes a perpendicular journey across this 45-degree line, and it lands right there. Now, what if we call this one B? So B prime is going to reflect this way. So here's B prime. It's going across like that. A prime went across like that. And then let's talk about this one. This would be C on our function. So it's going to scoot across something like that. Okay? So now that I have my 3 points, I just have to draw a line that connects them, and that line is going to be something like this. Now, I kind of curved that a little too far in. I think I didn't put that point quite in the right place. It should be a little further over. But I think you can see that here's my function g of x, and here's my inverse function, g inverse of x. And we just reflected it across this y equals x line. Okay, let's do an IB style question that pulls all of this stuff together. Okay, so here's our function, minus 5x plus 2. First part, sketch a graph of f of x. So here's how I'm going to do that. Here's my y-intercept. So that's the point here. That would be 0, 2. And then my slope is negative 5. So I'm going to go down 5 and over 1. So if I'm 2 up, I'm going to be minus 3 down and over 1. So that's going to be the point 1, negative 3, right there. And then my function is just going to go right through those 2 points. Pretty bad. Let's try that again. Better. Still a little bit wiggly, but that'll do for now. So here's my function of f of x. I just plotted 2 points using the slope-intercept form of the equation. Okay, let's do some problems here. B. Negative 1b, whatever that letter is, lies on f of x. Find b. Okay, so you've been asked this question a bunch of different ways so far in this section on linear models. What they're basically saying is that negative 1 goes into the function, what comes out? So negative 1 times negative 5 is 5, plus 2 is 7. So b would be 7 in this case. Okay? Next question. If x is between negative 1 and 2, find the domain and range for f of x and f inverse of x. So the easy part here is the domain is given to us by this. So the domain is minus 1, 2. That's easy. Now to find the range, we have to plug the minus 1 into our function. And actually we've done that already. We did negative 1 here. So the range is going to be 7. And then we plug the other one in to our function, which is 2. So minus 5 times 2 is minus 10, plus 2 is minus 8. So our range would be negative 8. Now, figuring out the domain and range for the inverse function, there's no figuring out. You just swap these two. So for here, we have The domain is 7 minus 8, and the range is -1, 2, like that. Okay, our last question here, I just added sketch f inverse of x. So go ahead and pause the video right now and see if you can do that in your notes. Okay, let's see how you did. I like this 45-degree line thing, so I'm going to just go, there's my y equals x line. Now all I need to do is reflect my points across this line. So the point 0, 2 is going to become 2, 0. That's right there. And then this point is going to become -3, 1. So we're going to put that up there. And there we go. Now we have our new line, like that. And there you go. Now you have, so remember, this is f of x, that line there, and this is f inverse of x. Just like that. Let's do one last problem. Now we're not graphing, we're just using a formula. In fact, the formula for the area of a circle. So area as a function of radius is pi r squared. Area depends on radius, so radius is independent, area is the dependent variable. So, first part, pause the video and do this. I'm not even going to say what this means, you should know now. So go ahead and pause the video, do this calculation. Okay, let's see how you did. What this is asking is for a radius of 2, what is the area? So we're going to do pi 2 squared equals 4 pi. For our purposes here, we don't need to take the pi out. In fact, it's easier if we just leave it at 4 pi. And there's plenty of places in mathematics where you don't do an approximation for pi, you just leave it there. Plus, that's exact. As soon as you approximate, it's not exact anymore. Okay, now here's the tricky question. How about the inverse area function for 16 pi? Now, there's two things here that are hard. First, figure out what that means, and then second, do the math on that. So, go ahead and see if you can figure out what that means. Pause the video and think real hard about that. Okay, let's see what you did. So the inverse area function is going to start with area as the input, as the independent, and it's going to spit out the radius that makes that area. So it's just doing it backwards. This one goes from radius to area. The inverse function is going to go from area to radius. So, see if you could write an equation where you would find the answer to this question. Okay, let's see how you did. So this is the area, and we're trying to find radius. So what we would do is you'd write 16 pi for area equals pi r squared. Now go ahead and solve that. This is pretty straightforward. Divide through by pi. We have 16 equals r squared, so r equals 4. So the inverse area function of 16 pi is 4. Now that you've watched the video, jot down some notes or questions for our next class. You can also re-watch the portions of the video that you didn't understand so well the first time. If you enjoyed the video, please click like, and if you'd like to help me grow my YouTube channel, please click subscribe.